This is the day 14 due now and the notes for lesson 4.2. If you haven't done so already, go ahead and complete the 2 questions on today's due now. Push pause, and when you're ready, push play and I'll go over the answers with you. Okay, if you remember from the previous lesson, when you have the word evaluate the expression, that simply means you're replacing all those variables with values that you are given. And I told you whenever you replace a variable to put it inside parentheses. So what I'm going to do is copy down what would be the original problem, but instead of writing any letters at all, I'm going to write a set of parentheses wherever I see a letter. Then you plug in the values for each one of the variables. Our first variable is x, so I have to plug in the -10. So I'm going to plug it in to that first set of parentheses. The expression says minus y, so I plug in the y of 5 and z, 3. Now I have a numeric expression that contains no variables at all, so I use my order of operations. Let me read the problem back to you so that you understand where to begin. -10 minus 5 times 3. When you have 2 sets of parentheses side by side, that does mean multiply, and that's the operation you need to do first. So 5 times 3 is 15. Copy down the whole rest of the problem, the -10 minus, and now we have 15. So now let me read the problem again. -10 minus 15, or another way to think of it is -10 minus +15. Remember, we never subtract integers. We always change it to an addition problem. So we have to keep our -10, change it to addition, and then change our 15. Keep change. Now we have -10 plus -15. This is when we use those rules of SOB. Are those the same signs or opposite signs? Because they're the same, we have to add. So 10 plus 15 is 25. And the bigger sign wins. Don't forget that last part of the rule. Because they're both negative, your answer has no choice but to be negative, but -15 is bigger, or the 15 is bigger than 10, so that's where we get the negative sign from. So your final answer should be -25. So question 2. Why, when you replace a variable, is it recommended to use parentheses? Let's explain it using reasoning, and problem 1 is an example. In the future problems, like in the ECA, you may have to explain why you're doing something with a problem or reasoning for something. So let me explain it with maybe a counter example. If I don't use those parentheses, let me show you what the problem looks like. I replaced some of my variables, didn't I? But look at the problem. It looks like I'm saying -10 minus 53. Instead of 5 times 3. So why do we replace variables that recommend to use parentheses? Say otherwise. Well, let's put it this way. I don't have room to write with the stylus because I can't write very good. So let me show it to you just in print. Without the parentheses, the problem would look like -10 minus 53, and you would not recognize the multiplication of 5 times 3. Instead, it would appear to be the number 53. There we go. So now we begin with lesson 4.2, evaluating expressions with parentheses and exponents. The one I had in the previous one did not have either one of these. Some expressions contain parentheses before you even add them when you replace variables. And this can make the problem look very chaotic. Let's look at this example that I've given you of x, you see it right here, xy times the quantity z minus a minus b squared. It doesn't look that complicated when we have just our variables in it, but then when we replace with our variables and we put them inside parentheses, this looks like a hot mess. And I wouldn't want to solve that either. It's doable, but the parentheses are going to start to get really confusing. So I'm going to make some more recommendations. Now, other teachers may have showed you different ways in the past, but this is just another way to break it down and make it look simpler. Parentheses in original expression are always needed. You have to have them. You can't drop them. So what I do to make them very important is I change them to brackets. So these two parentheses up in this part of the problem, what I did is I replaced them with a bracket symbol that looks like, let me draw one real quick for you. They look like this. There's the open and here's the close. If you're typing, it's above your enter key. So the brackets act just like a pair of parentheses. Whenever you see them, you have to do what's inside of them first. So let's look at this example now that I used the brackets instead of parentheses. Even though it might look a little bit better, I still think we can put a little bit more improvement to this. So here's some quick tips for you for changing the problem so that it prevents you from making some calculation mistakes. Step 1, replace any original parentheses in a problem with your brackets. That's what I recommend at first. You can see the same problem with our parentheses. Step 2, separate any side-by-side variables with a multiplication dot. So let me show you where that's at. In the problem right here, we have an x and a y that are side by side to each other. That means that the two variables are being multiplied. Just to make that very clear when we replace those variables, let's separate those two and put the multiplication dot in between. Next, you will separate any variables that are side by side with a bracket. And notice that I have the open bracket. We're not concerned with the closed bracket. So this bracket right here in the problem, see how we have that y variable that's right beside it? I'm going to also put a multiplication dot to separate that. You don't have to, but it sometimes helps when we have numbers to remind us that that means multiply. And then replace any variables that have a negative sign with the parentheses. So we don't always have to use parentheses to replace every variable, but negative numbers are important. They do funny things when they're next to other signs. For example, another negative sign or a subtraction sign. So to make it clear that we know that that means it's a negative number and not a subtraction, if you have any negatives, then we will replace those. So our variable x was a negative number, so I replaced it with the -2 inside parentheses. The a value that you were given up in the original problem. This is a of -3, so I replaced with the -3 in parentheses. All other variables, we can go ahead and plug in and replace their variables, and we don't need to use the parentheses. For example, y, that's right here, we don't need to put it inside another set of parentheses. Y is equal to a +3. Let's just plug it in. And where was I? Sorry, I lost track of myself. And we still have the b variable to replace, and b is a +2. So that's why we replaced it with a +2. Now that we have all numbers, no variables, we can use the order of operations, and we can clearly see what our operations are now. Let me read the problem back to you. -2 times 3 times the quantity of 4 plus 3 minus 2 squared. I think if we write it this way, you can clearly identify your operations and you're less likely to make mistakes. So what would you have to do first? Order of operations is you do whatever in parentheses first, or in this case, our brackets. That -2, yes, we see that it's inside parentheses, but if you only ever have one number in parentheses, there's nothing to do with it. So the 4 plus 3 is what we need to tackle. 4 plus 3 equals 7. So we copy all the rest of the problem down, but now replacing what was in that bracket there with the 7. We can drop the brackets at this point if it's the only number. Continuing on, what's next? After please excuse, what does excuse stand for? Hopefully you said exponents, so we have to solve the 2 to the second power. 2 to the second power is 4 because 2 times 2 is 4. We're not because this is 2 with the 2 up in the air, we're multiplying, but this is 2 times. So that equals 4. Alright, what operation do we do next? If you get stuck, you don't know, then read it out loud. Negative 2 times 3 times 7 minus 4. Order of operations says we always do multiplication before we do any subtraction. So we have 2 multiplication symbols. Which one do we do first? Well, if you have many, then you always work from left to right. So negative 2 times 3 is negative 6. And then negative 6 times 7 is negative 42. We keep on just bringing down the 4. Now we have the problem of negative 42 minus 4. I probably should have showed one more step at this point. Let me write that in. Negative 42 minus 4. Do we ever do subtraction with integers? No. So you can rewrite that as negative 42 plus a negative 4. So remember that symbol in between there is subtraction. That means that 4 doesn't have a sign with it. It means the original problem is positive, therefore we have to change it to a negative. Now we have negative 42 plus negative 4. We use our SOB rule. Those are both the same signs, so we have to add. 42 plus 4 is 46, and the bigger sign wins. So that's how they got negative 46. Don't worry, we'll do plenty of examples together. Now those steps that I just showed you, 2 through 5, can even be applied to problems that do not have parentheses and make even them look simpler. Let's try this with the do now that you had at the beginning. When we filled in all those variables with parentheses, that's a lot of parentheses too, so to think of it. But we can use those same steps with the same problem. So in the first step, what did I do? I separated, the original problem was x minus yz. I know you can't see it on my video right now because I can't scroll up to the top and show you at the same time, but you have it on your paper in front of you. So what did I do? The first thing I did is if I saw any variables that were side by side, for example that y and the z in the original problem, I put some space in between and put the multiplication dot in between. Then I replaced any, if I had parentheses in the original problem, I would replace them with brackets, but this one didn't. And then I replaced any negative variables, but making sure that I put them inside of parentheses. Finally, replace any variables that were not negative. So you can see what I did there. I replaced the x with negative 10 inside parentheses. I copied down the minus side. I filled in the 5 for the y value and the 3 for the z value, but I didn't need to put them in parentheses because they were not negative values. Reading the problem out loud, it's negative 10 minus 5 times 3. So the next operation I needed to do was the multiplication of 5 times 3, which equals 15. I have a negative 10 minus 15. We do not subtract with integers, we change it to addition, so we had to keep our negative 10, change the subtraction to addition, and change the sign of this positive 15 here. So it was a 15, I changed it to a negative. I have the addition of 2 negative integers. Are they the same signs or opposite signs? They're the same, so I have to add. 10 plus 15 is 25, and the bigger sign wins is the negative 25. For those smaller, less complicated problems, yeah, it's probably just as easy just to fill in every variable with inside the parentheses, just so that you get your signs right. But definitely when you get into these more complex problems or ones with parentheses and exponents, I would use the brackets for the parentheses and then only replace negative variables with their value inside of parentheses. The positive variables you can just write in. Alright, turn the next page to your practice worksheet, and instead of me just giving you the answers for the correct and check, let's go ahead and at least do a couple more problems together. Pause if you want to give it an attempt, and then push play if you want to check yourself right afterwards. But let's just at least do problem number 1 together. So this is your first problem on your worksheet. C plus A to the second power. Use A as -4 and C equals 6. So if you looked back on my steps, one of the steps I said is to replace any parentheses with brackets. So I'm going to copy down the problem. I'm not going to replace everything just yet. When you get better at this, you can start replacing everything at once. So replace the parentheses with brackets. I fill in any negative variables with inside of parentheses. So my negative variable is my A. Therefore, where the A goes, I'm going to make a set of parentheses and plug in that -4 there. Copying everything else down. So C plus square. And then the only variable I have left in my problem to plug back in is the C. And because it's positive, I'm just going to write it in as plus 6. I don't need to put it inside parentheses. Okay. So that's what our problem looks like when we start to use the order of operations. You can clearly see that this is 6 plus a -4 now. So ask yourself, same signs or opposite signs? They're opposite, so you have to subtract. 6 minus 4 is 2. This is inside of our brackets here. So we did everything inside the brackets, but we got this 2 up in the air. That's your exponent. You don't have to do that after you do what's inside parentheses, then you go to your exponents. We only had to do the addition of those integers because the rule says do whatever's inside the parentheses first, regardless of what's outside. 2 to the second power then equals 4. And that's your final answer. Let's do another one, and I'm going to go a little slower just so that I'll give you time to fill in and answer these as well. If you haven't finished copying this problem down and all the steps, then go ahead and push pause and finish copying it. Alright, problem number 2. What's the first thing you need to do? You need to remember, look back on your notes. You recopy the problem, but this time use brackets instead of parentheses. Okay. Now looking at our variables, do we have any negative variables? Not this time. So this is going to be pretty nice. We can just replace all of our variables. So P is equal to 3, P is equal to 3, and R is equal to 6. I think in my notes I told you if you had an open bracket and a variable that you could put a dot in between, you could still do that just to help your mind. Oh, that's 3 times whatever's in that parentheses. So you 3 times 6, or 3 plus 6 is 9, and 3 times 9 is 27. Go ahead and finish copying it if you're not done. Now, as I said before, as you get a little bit better at these and used to it, you can kind of do all your steps at once. So, for example, if I look at R is a positive number, so I'm just going to copy it down. Oh, there's a parenthesis, make a bracket. Copy down your -3. Yes, I know it is a negative number, but it's not a variable that I replace, so I don't need to put an extra set of parentheses around it. Plus P is a negative number, so I'm going to put it inside parentheses. And then the final closed bracket. Now I have the problem. Oh, because I had that variable in parentheses, I could put the dot in between there. I have 6 times the quantity of negative 3 plus negative 2. So 6 times, well, negative 3 plus negative 2. Those are the same sign, so I have to add, equals negative 5. Bigger sign wins. And 6 times negative 5, well, 6 times 5 is 30. And those are opposite signs, right? We have a positive and a negative. Oh, that doesn't look too happy. Our answer is negative. So number 4 has a little bit interesting scenario going on. I'm going to go ahead and copy everything just using what I have. This negative sign, change the parenthesis to a bracket. C is a negative number, so I put it inside parentheses. Minus, and A is also a negative number. So I'm going to write it inside parentheses, and then because there's a final parenthesis in the problem, in the original problem, I'm going to replace it with a bracket. Alright, you do what's inside parentheses first, so copy down that negative sign on the outside. I could put a dot there, but then, well, I'll get back to that here in a second. I have a negative 3 minus a negative 5. Can't subtract, we change it to an add. So we keep it, the first number, change it, and change it. Keep, change. Negative on the outside. Negative 3 plus positive 5. Those are opposite signs, so we have to subtract. 2, and the bigger sign wins, so it's a positive 2. Now this negative sign that keeps on floating around here, put it that way. That negative sign, whenever you see a negative sign next to a parenthesis or a negative sign next to a bracket, what this actually is there is an invisible 1 here. So this is like saying negative 1 times 2. This is going to be pretty important, even going in through algebra, that you know that that's actually an invisible 1 that lies between a negative symbol and a bracket or a parenthesis. So negative 1 times 2, well, you have a negative and a positive. Oh, that's not good, right? Equals a negative. 1 times 2 is 2. You think you've got this yet? Well, here's what I'm going to do. For the next 4 problems, I want you to go ahead and push pause, do the entire problem on your own, and push play to check and hear me how I explain the problem. We'll do that for the next 4 problems. Then problems 9 through 15, I want you to do completely on your own. I will add the self-check and correct so that you can open it up and see the answers for those and correct yourself and see I'll just have the final answers for those. Ask if you need more help. Let's look at number 5 whenever you're ready. You do the problem first. Push pause until you're ready, and then push play when you're ready to see the answers. Okay, so you're ready. Y is a negative 1. I'm going to replace it and put it inside parentheses to the second power, plus Z is a positive number, so I just write it down. Negative 1 to the second power, well, a negative 1 times a negative 1 equals a positive 1. Plus the 3, and 1 plus 3 equals 4. Did you get it right? Check your work. If you made any mistakes, go ahead and correct it now before you push play to check the next one. Right. Go ahead and try number 6 on your own. When you're ready, push play. Alright, in this one I have some side-by-side variables. Yes, there's that squared symbol in between, but I'm going to go ahead and recopy this as h squared times with the dot k just so that if I replace anything, I do know that those need to be multiplied together. H is a negative number, so I'm going to put it inside parentheses. Copy down your square, that doesn't go away, times K. K is a positive number, so I can just write it. Negative 3 to the second power. Remember, that's the same thing as saying negative 3 times negative 3, which is equal to a positive 9, because a negative and negative gives you a nice happy person. Times the 3, so 9 times 3, that is 27. Correct if you made any mistakes. Watch your signs. When you're ready for problem, go ahead and push pause now and complete problem 7 and push play when you're ready to check that one. Alright, on this one we have a set of parentheses in the original problem, so rewrite it as R parenthesis negative 6 minus P parenthesis. Okay. I could have started filling in everything all at once, so if I did that, I would have filled in the R, which is a positive number, bracket. You can even put the times in between because we did have that variable in bracket to separate. Negative 6 minus, and P is a positive number, so 6. The dot that I recommended between a variable and a bracket, as I'm going through this, that's really not as important, as long as you know that if you have any number at all side by side to a parenthesis or a bracket in a numeric expression, then that means to multiply. Alright, so we need to do what's inside the brackets first. 4 is negative 6 minus 6. Can we do that? Not like that, you can't. So rewrite it. Keep, change, change. So 4 times, well, negative 6 plus negative 6 equals a negative 12. You would multiply 4 times 12. You're gonna laugh at me. I cannot do that horizontally. I have to actually see it like this. Most of you can do that in your head. I'm just one of those people that cannot. 4 times 2 is 8. 4 times 1 is 4. It's 48. Positive times a negative equals a negative. So your final answer is negative 48. One more that I'll do with you in the video. So you're going to complete problem 8, push pause and push play when you're ready to check it. Alright, let's see how you did. M is equal to 6. That's a positive number, so just write it. Minus, change that original problem parenthesis to a bracket. P is equal to negative 5, so I need to put it inside parentheses. Plus 4. Doing with just what's inside of those brackets first. Negative 5 plus 4, those are opposite signs, so you have to subtract. It's equal to 1. And the bigger sign wins. Well, 5 is bigger than 4 and it's negative, therefore it's a negative 1. Copy the rest of the problem down. So the problem now reads 6 minus negative 1. We do not subtract, we change it to addition. So we keep, change, and change that negative 1 to a positive 1. Because it turned to a positive number, I no longer need it inside of parentheses or brackets to make sure that I don't make mistakes. So you'll notice that sometimes I'll keep the parentheses as I'm going along, sometimes I'll start dropping them. When I added those two numbers together because my answer was still negative, I kept the brackets that you see here. I could have changed them to parentheses. They mean the same thing. 6 plus 1 is 7. How'd you do? If you got that one right, put a smiley face right next to the problem. This will show me on your paper that you are actually watching these videos. So give me a big smiley face if you got it right. If you got it wrong, Well, I don't want to be mean. Don't give yourself a smiley face, though. Give yourself a straight face, okay? If you missed it, at least if I see a face on your paper, then I know you really are truly following along with these videos and not just trying to jump ahead and skipping over my suggestions and things. Alright, go ahead and finish the practice. There's more problems on the back of this page, and when you're done, you're going to click on the self-check and correct, and I will only post then the answers to those problems on the back. All these answers are in this video, so if you need to go back and see them again, you can.